Welcome or welcome back at C Square. In this lesson we will talk about how to prove that two lines are parallel, and we're gonna use this what is called the converse of some theorem. And the first converse you see here on the screen is the converse of consecutive interior angles theorem, which says if two lines in a plane are cut by a transversal, so that a pair of consecutive interior angles is supplementary, then the lines are parallel lines. So what do we mean here? If you notice, this angle 3 and this angle 6 are consecutive interior angles. They are on the same side of the transversal T and they are interior angles. If these two angles are supplementary, then the lines are parallel. So it sounds something like this. If the measure of angle 3 plus the measure of angle 6 equals 180, then line A it's parallel of line B. But this is not the only pair of consecutive interior angles. We have another one, 4 and 5. And we can write something very similar. If the measure of angle 4 plus the measure of angle 5 equals 180, then these two lines, A and B, are parallel lines. That's what this converse of consecutive interior angles theorem says. The next one we're going to look at is the converse of alternate interior angles. And let's take a look to this picture. If you notice, angle 3 and 5 are alternate interior angles. They are between line A and B. One is on one side, the other one is on the other side. So we have two alternate interior angles. If these two angles are congruent, these two alternate interior angles are congruent, then the lines are parallel. So I'm going to write here, if angle 3 congruent with angle 5, then A parallel with B. Is that the only pair of alternate interior angle? The answer is no. We have one more. We have 4 and 6. And 6 and very similar, we can write a conditional statement. If angle 4 congruent with angle 6, then A parallel with B. Another converse. Now this one is about alternate exterior angles. Let's take a look. If these two angles, which are alternate exterior angle, you notice they are outside of A and B, one on one side, one on the other side. If these two angles are congruent, these alternate exterior angles are congruent, then the lines are parallel lines. So a very similar conditional statement here. If angle 1 congruent with angle 7, then A parallel with B. Is this the only pair? The answer is no. We have one more. Angle 2 and angle 8 are alternate exterior angle. If these two angles are congruent, then A and B are parallel lines. Okay. And we have one more, which is the talking about corresponding angle, converse of corresponding angles. Now here be careful because you have more than two pairs. We have one here, 1 and 5, and again these corresponding angles, they need to be congruent in order for the two lines to be parallel. So I'm going to write a very similar statement to the previous one. If angle 1 congruent with angle 5, then A parallel with B. Case 2, about the same theorem. Now we have this angle 2 and angle 6, corresponding angles. So we have if angle 2 congruent with angle 6, then A parallel with B. And like I said, in this case we have two more, 3 and 7. If angle 3 congruent to angle 7, then A parallel with B. And 4 and 8. So in this case we have 4 pairs. Remember, for corresponding angle we have 4 different choices to use this converse of corresponding congruent angle. So if converse of corresponding angles theorem, if angle 4 congruent with angle 8, then A parallel with B. So now on my next thing is going to be an example. Use the diagram below, and on part A we know, given that angle 1 congruent to angle 9, determine which line, if any, are parallels. So first of all, I will suggest you to look to angle 1 and 9. You notice where these angles are located, right here. I will suggest you, if that is needed, of course, to redraw the picture only with the lines you need. You see we have 4 lines here. But which one I'm going to draw here? I'm going to draw this one, A. And A, if you take a look, is the transversal. And then M and N. M. And N. Now I think that helps us to say this is angle 1 and this is angle 9. What type of angles are angle 1 and 9? If we look to this picture, we notice this angle 1 and 9 are what we call them corresponding angle. Okay. And don't we just have had a theorem that said if two corresponding angles, in this case 1 and 9, are congruent, like in this case, then the lines are parallels. Which one are the one that can be parallel? M and N. So that justifies your answer. Okay, these two angles are corresponding angles, then M parallel with N. Let's go to the second part, very similar. Now we have angle 3 and 6, and this statement here says supplementary, right? Angle 3 and 6. Again, if it's needed, you can redraw the picture. What I'm going to eliminate in this second picture, I'm going to eliminate this line N because in fact I don't need it, right? So this is the line M, and if you notice, line M is the transversal now. I'm going to need this line A and this line B, and these are angle 3 and 6. If these two angles are supplementary, yes, we can say what line? A and B are parallel lines, right? Angle 3 and 6 are consecutive interior angle or same side interior angle. Okay, if two consecutive interior angles are supplementary, then the lines are parallel. So here in this case, which lines? A and B. And we justify our answer. We use the converse of consecutive interior angles. On the next problem, we have to really look and find the value of x for which these two lines are parallel. So we need to prove these two lines, A and B, are parallels. Obviously, M is the transversal. What kind of angles are these two angles if we look to these two angles? One is on one side of the transversal, the 3x plus 7 is on the left side, and 79 degrees is on the other side of the transversal. They are both interior angles. So if I call this angle 1 and angle 2, I'm going to say here if angle 1 and I set these angles to congruent of angle 2, then A parallel of B, right? This one is the converse of alternate interior angles, right? So in order for these two lines to be parallel, these two angles needs to be congruent, which means the measure of angle 1 needs to be the same with the measure of angle 2, which means in fact the equation that you need to solve it, we need to solve it, 3x plus 7 equals 79. That will allow us to get a value of x. I'm going to subtract 7 to get rid of this 7, and I have 3x equals 72 divided by 3, and that will be 24. If x is 24, then then this angle here will be 79. This is 79. They are congruent angles. They have the same measure. Therefore, A and B are parallel lines. So that's about this problem. And some of you may start only with this algebraic statement. Let's take a look to the next example. And again, we need to prove line A parallel with line B. Obviously, this M will be the transversal. I'm looking to this angle here. And this angle, by the way, because the picture is accurate, notice they are not congruent. And what are the name of this angle? They are on the same side of the transversal M and interior. They are consecutive interior angle. So if I call this angle 1 and angle 2, my conditional statement will be if measure of angle 1 plus the measure of angle 2 equals 180. Why? Because they are consecutive interior angle or same side interior angle. Then A parallel of B. This is my justification. This is the theorem. I'm going to use it. And in this case we have what? 124. That's his angle 1 based on my picture. So let me be consistent. 124 plus 4x plus 8 equals 180. We have an equation. The first thing I'm going to do, combine these two numbers. That will be 132 plus 4x equals 180. I'm going to subtract 132 on both sides. I have 4x equals 180 minus 132. That is 48. And divide by 4. X equals 12. So we finished the problem. If you want to check it, just plug it in. Here 4 times 12, it's 48 plus 8, 56. If you add this 56 and 124, you notice you get 180. Those two angles are supplementary. Therefore, A and B are parallel lines. This is the example that you really need to be careful about, okay? Because we do not have a pair of angles like this. This is exterior on the same side of transversal, but we do not have a theorem. However, this angle here, if this congruent to this angle here, if those two angles are congruent, then we can use the converse of alternate interior angle. I can say something like that. If angle 1 congruent to angle 2, then A parallel of B. But then we look into this angle, and obviously angle 1 and angle 3 needs to be supplementary. So that's gonna be my statement here. Measure of angle 1 plus the measure of angle 2 equals 180. Now angle 1, since is congruent to angle 2, the measure of angle 1 will be the same with measure of angle 2, so that will be 4x plus 9. So now what will be this statement? I'm gonna have 4x plus 9 plus, and I'm sorry, I should have had angle 3 here. Right, these two angles needs to be supplementary to form a line, plus 5x plus 18 equals 180. So obviously some of you may go and say directly this statement. You take a look to these two angles. The picture is not bad, it's pretty accurate, and you can notice these two angles are not congruent. The other property is to be supplementary, and you can write this statement right here. So we have here 9x plus 27, right? 9x, we add these two guys, 9 plus 18, 27 equals 180. I'm gonna subtract 27, and I have 9x equal 180 minus 27, and that will be 153. Divide by 9 to get rid of the 9. And we end up with 617. Okay, so that is the value of x for which these two angles here are going to be supplementary. Let me just check very fast. What do we get here? 5 times 17 plus 18. That will be 103. And let's hope this one will be like a 77, I guess. Let's double check. 4 times 17 plus 9, 77. You notice now these two angles are supplementary, so these two lines are parallel lines. But again, we do not have a straightforward theorem converse for this type of angles. We kind of use a little bit of more critical thinking, logic. However, for this example here, what converse we can use in order to prove that line A and B are parallel lines? We're looking here, and again we notice something that we had before. Okay, these two angles are corresponding angles, so they need to be congruent. So I'm gonna just write here 2x plus 34 equals 4x minus 12. That will be the converse of corresponding in angles. And then we have an equation with x on both sides. So I'm gonna personally subtract 2x on both sides. And I have here 34 equals 2x minus 12. I'm gonna add 12. And we have here 46 equals 2x divided by 2, and x equals 23. So if x is 23, let's see what do we get here for x plus 12. That will be for x minus 12, I'm 30. 4 times 23 minus 12, that will be 80 degrees. And let's hope this one is 80 degree also. 2 times 23 plus 34. Yeah, exactly 80. So yeah, these two angles now are congruent because they have the same measure, 80 degrees. So these two lines A and B are parallel lines, and we use the converse of corresponding angles. Okay, now sometimes you have multiple lines like in this case, and you still need to find the value of x for which these two lines A and B are parallel lines. So if you take a look, maybe you want to eliminate something that is called distractor in math problem. Which one is the distractor here? The distractor here is this guy. Don't really need that. And in fact, you don't even need this line D. It's kind of a distractor here. So what you're looking for, it's A and B. And this line C is going to be the transversal. And now I'm looking to these angles. What kind of angles are these two angles? So you may want to redraw the picture. I guess maybe it helps. Something like this, and these two angles. Okay, these two angles for sure are not congruent, right? So I'm gonna mark it like this. Okay, they are none of those angles we had before, but we have an example just 2 slides ago, I guess, where we kind of said, hey, this angle here and this angle here are corresponding angle. If these two angles are congruent, then A and B are parallel lines. And then this angle, it's 1, 2, and 3. Then angle 2 and 3 needs to be supplementary. So this is kind of the idea I'm going to use it here. This angle should be 7x plus 20, and then A and B are parallel lines, and then these two angles needs to be supplementary. So that's my equation here, 7x plus 20 plus 8x minus 5 equals 180. And then we have 7x plus 8x, 15x plus 15 equals 180. Subtract 15 on both sides. And we have 15x equals 165 divided by 15. And that means x equal, I think 11, but let me be sure. Yeah, x equals 11. So yes, we did find the value of x, that is 15, for each these two lines are parallels, because then these two angles we have in the picture are going to be supplementary. You can check it if you want, replace x with 11 on both expression, and then whatever you get, add them and you should get 180. Finally, on this lesson, we'll take a look to a proof. Okay, how can we write a proof for this converse, perpendicular transversal converse? If you notice here, we have given that M is perpendicular on A. We can see the right angle here. Also, M is perpendicular on B. Can we prove that A parallel with B? And that looks like common sense here. Let's write a 2-column proof. I will do it. And I'm going to put here statements. Reasons. let's take a look to this one. What am I going to start? You always start with what is given, and what is given to us is M perpendicular on A. This is given, and based on this statement I can say this angle 1 here is 90 degrees, right? So right angle, I can write this angle 1 right angle, and this will be definition of perpendicular line. And then I can write here the measure of angle 1 is 90 degrees. This is the definition of right angle. Very similar, I can do the same for angle 2, the one we have here. I'm gonna start with M perpendicular on B, and that is given. And I'm gonna skip this step if you don't mind. And I'm gonna say here measure of angle 2 is 90 degrees. Why? Because that's his definition of a right angle. But now let's take a look to these two statements. If we notice angle 1 is 90 degrees, angle 2 is 90 degrees. So that tells us the measure of angle 1 is the same with the measure of angle 2. Both of them are 90 degrees. And here is an algebraic property. I'll say here you can use either transitive property of the equality, but I think here we can use better the substitution property. But either one I think will be good. Substitution. I think I misspell it. Let me. Substitution property. Substitution property. Okay, and now what's happened if these two angles, angle 1 and 2, have the same measure? Obviously they are congruent, and that is the definition of congruent angles. And if these two angles are congruent, what can we say about A and B? They are parallel lines. Why? Because these two angles are corresponding angles. So here will be the converse of corresponding angle. Okay, so this is a proof about this perpendicular transversal converse. You see here the theorem in a plane. So that works only in a plane. If two lines are perpendicular to the same line, then the lines are parallel. So from now on, you can just use this theorem because you prove it. You don't have to prove it one more time. If you enjoyed this lesson, don't forget to click the like button and come back on C-Squared for more help. Thank you.